Attendance. Roll number with name. Okay, so in the last lecture, if you remember that we studied the multiplexer, right? And we realized or implemented Boolean functions using multiplexer. So at the last problem, the last problem was the implementation of full adder using the multiplexer. Okay, so we will continue with that. I will show one more example of the implementation of Boolean function using the multiplexers, and then we'll shift to the higher order implementation, higher order multiplexer implementation using the lower order multiplexer. So this is the question here.
Sir, excuse me.
Yes.
Sir, that side is not visible.
I hope now it is visible.
Yes, sir.
This is the Boolean function, and the question is implement this Boolean function using decoder, that is 4x1, sorry, using multiplexer, that is 4x1 multiplexer. Four is to 1 mux. So if you remember, how will you proceed? You have this 4x4:1 multiplexer, and it will have, surely it will have one output. Okay, and based on the selection lines, according to the selection line, one of this input will be selected, and this input will be reflected toward the output. So let me call this I0, I1, I2, and I3, and I have these two selection lines. So now the question is, realize this function, this Boolean function, using this 4x1 mux. So how will you proceed? So I told you in the yesterday class or the last class that you will have to decide two variables as this selection lines. Okay. So now which min terms this will hold? We can see using the truth table, or also you can use the K-map. So if I write this A, B, C, zero, 1, 2, 3, and 7. So is it correct? These are the min terms which this function holds. Is there any problem to realize this? Okay, for A is equal to 0, this term will have four min terms: A bar, B, C, and with B, C there are four combinations, and all will be 0, 1, 2, and 3. And this is BC. So what is this? Which variable is absent here? A. So we'll add BC, A plus A bar. So this will be ABC, and this is seventh min term, M7, and A bar BC. So this will be what? Third min term. That's why we want to realize this function. These are same. This is written in form of Boolean function. This is written in the form of mean terms. Okay. Now I choose that assume or consider let B, C are considered as these selectors. So here I will put B and C. Okay. So how do you write this function? Let's suppose this is y. So how do you write y? Y will be what? In terms of this selection lines, I can write S bar, S naught bar, S1 bar into I naught plus, I should write it S1 and S0. Again S1, S naught, I1, then S1, S0 bar, I2, then S1, S0, I3. Isn't it? And now if we connect this S1 to B and S0 to C, then this is our S1 and S0 will become now B and C. Now what we want, we just want this inputs to be chosen in terms of A or 0 or 1 according to the mean terms. Which mean terms is available in the function? According to that, we will choose here, we will connect the variables, third variable, remaining variable. Okay. So if I write this whole equation in the form of Boolean function, so I can write it like A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C bar plus A bar, B, C plus again A, B, C. So for B bar, C bar, here it is B bar and C bar, I0 should be connected to A bar, correct? So this way we'll connect, but we will not go using this Boolean function, we'll go through the K-map. That will be very easy. So now we'll draw the K-map here. I have this K-map here, B, C, A and B. These are capital, sorry. B and C. So this cell will be 0, 0. This cell will be 0, 1, 1, 0, and 1, 1. Okay, now for this mean term, I have 1, again 1, this one, and this one. And for this. So this 0, 0, when the BC is 0, 0, so the whole this cell is associated with the input I0. When this cell is 0, 1, this is associated with the I1. So what should be the value of I0? So I0 is nothing but A bar. Here I1, A bar again. I2, A bar again. And I3 will be 1. I3 will be always 1 regardless the value of A, regardless the variable A. So here I will connect A bar to all these 3 and I3 will be 1. Always remember, whenever you are realizing or implementing any Boolean function using mux, so no need to write the exact K-map. Actually, if you see here, when you write the K-map, you put 1, 1 here in this place and 1, 0 in this place. But if you go like that, then you should remember this will be I3. Because whenever you give 1, 1 at this selection lines, this I3 will be selected. So we made this mistake in the previous lecture also. In the previous lecture, when we were solving the full adder, we did that mistake. So correct it there. I wrote there 1, 1 and I assigned this as I2. It was I3. Okay. So can you solve any question with 4 variables? A, B, C, and D I have, and these are the minterms given. And can you solve this for using, can you implement this Boolean function using 4 cross 1 multiplexer? So how will you proceed? See, I'm quickly solving this question. I will not take much time for this because this is very easy. But I want to show the K-map. Actually, the people makes mistake there. So what is the first procedure? You need to assign these selection lines. And always remember this selection line should be your LSB site. Okay, it's A, B, C, D. This CD I consider as a selection lines, because in this way the question will be simple. Otherwise, you will face the problem when you solve or when you try to obtain what should be connected at these inputs. Okay, now this is my 4 cross 1 mux, and these are the minterms given. So this C and D now will be what? Your selection lines. And AB will be the variable that should be connected to the inputs. Now this cell will be associated with the input I3, and this cell will be associated with the input I2. Remember this. And now 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13. So here for this CD, when CD is 0, 0, and this whole 4 cells, the group of cells is associated with the I0, so I0 will be 0 because there is no high value, there is no 1 inside this. So this should be connected to 0. And here all are 1s, so I1 will be 1. And now for I3 I should connect 0, 1 here. So I3 will be what? A bar and B. We need one AND gate here, A and B. And for this, I2 will be A bar, B bar. A bar, B bar means what? A, B. So this way, either you can connect here one NOR gate, because NOT with AND is similar to NOR gate. With the De Morgan's theorems. This is the implementation of De Morgan's theorem. So this way, this whole mux will result this given Boolean function, and S1 was C and S0 was D. Okay, so here we have completed the implementation of Boolean functions using the multiplexers. And I assume that if any questions comes regarding this implementation or realization of any Boolean function, you can easily solve this. Now we'll move on and we will see the implementation of higher order multiplexers using the lower order multiplexers. So that is also called a multiplexer tree. Okay, see, if I draw like this, so let's say this is output and these are the inputs. So total, this is a 8x1 multiplexer, isn't it? However, we have used here that 2x1 multiplexer, again 2x1 multiplexer, 2x1 multiplexer, and similarly here also. So 1, 2, 3, 4, 5, 6, and 7. So you can answer also to if anyone want to realize 8x1 multiplexer, how many 2x1 multiplexer will be needed? 7, isn't it? So we'll see this implementation. So the first question is realize or implement 4x1 multiplexer using 2:1 multiplexer. They both are same. Okay, if you write 4x1 or 4:1, both are same. So one thing is clear that you need at least 2 multiplexer at the first stage, because 2x1 multiplexer will have only 2 inputs and you need 4 inputs. Correct? 2 multiplexers will be needed at the first stage here. And if it is a 4x1 multiplexer, it should have 4 inputs. Now see, for a 4x1 multiplexer, I should have only 1 output, but here I have 2 outputs. So how this question or this problem will be handled? This will be handled by another multiplexer. And each of this multiplexer will be having a selection line. So for 4x1 multiplexer, excuse me. Hello? Sir, in the class. Right now. Okay, so see this truth table with 2 selection lines. Let's suppose I assign as S1 and S0, 0, 0, 0, 1, 1, 0, and 1, 1. So when 0, 0 for a 4x1 multiplexer, for 0, 0, which input should be selected? I1. Okay, do you remember this? Because this is my 4x1 multiplexer, and if I have 2 selection lines, So for the combination 0, 0, this I0 will be selected. So y will be I0, and this will be I1, I2, and I3. And when I say I0 and this is I1, you are also not saying this. This is written wrong. Actually, you are not present physically here. All candidates, all students have focused on their quiz. There is no surprise for this quiz, right? Okay, so when I say, see, I0 and I2, there is a similarity. When S0 is 0, S0 is 0, this I0 and I2 is selected, isn't it? So it means that if I put here as 0, I assign this selection line as I0. So I0, whenever I0 is 0, this I1 will be selected. And here for this marks, S0 will be 0, so this I2 will be selected. And if I assign this selection line as I1, so my job will be done. When S1 is 0, so this part will be selected. It means when S1 is 0, I0 and I1 will be selected here. And when S1 is 1, this I2 and I3 will be selected. So only thing you should be focused, or you should give your attention here, that this selection lines, if you put this reversely, your whole question or whole solution will be wrong. So remember one thing, this MSV of selection line will always come near to the output. MSV of this selection line, that is S1, will always be assigned to the near to the output mux. And as we have saw that in the decoder implementation, for this type of questions, how do you obtain the number of this module which is given? So the required module divided by the given module. Here we will have 2, again we will divide by this 2, so 1. So 2 plus 1 will be the answer. 3, total 3 number of 2 cross 1 multiplexers will be needed to implement 4 cross 1. So the next question is implement 8 cross 1 multiplexer using 2 cross 1 multiplexer. So I need answers from you guys, that how many 2 cross 1 multiplexers will be required? 7. Yes, we saw that using that tree. And it is easy also. 7. Okay, so quickly reply me. If I need 7 multiplexers, so they must be arranged in this manner. And if I say S3, S2, and S1 will be the selection line for 8 cross 1 multiplexers, so which selection line will be connected to this selector? S3. Very good. And all this will be connected to S1. So the next question is implement 8 cross 1 decoder using 4 cross 1 8 cross 1 multiplexer using 4 cross 1 multiplexer. Is it possible? 8 cross 1 multiplexer using 4 cross 1 multiplexer. So first of all, the question is how many multiplexers will be needed, and is it possible or not? Yes, actually it can be implemented, but using the enable input, of multiplexer. The question was, you implement 8 cross 1 multiplexer using 4 cross 1 multiplexer. So it is clear that 2 multiplexers will be needed at the first stage. So we will be having total 8 inputs from 0 to 3 in the first multiplexer, and from 4 to 7 in the second multiplexer. And it will be having 2 selection lines. And if you write 3 variable CAMAP, it will be very clear to you which variable should be connected to which selection line. Tell me. BC should be connected to here. And to operate this multiplexer, means to operate these mean terms, we should work on this multiplexer. So enable input will be connected to a NOT gate and then variable A. It is capital here. And this will be connected to enable input of this second multiplexer. And now the question comes. It should have only one output. Then what you will do? No. Yes, of course, 2 cross 1 multiplexer can be chosen, but it will need another selection line. So we can put one OR gate. Yes, of course we can do, but questions comes like that. Implement 8 cross 1 using 4 cross 1 and other logic gates. Because this logic gate also needed here. We will require this logic gate. You were not present in my previous classes, and even you not saw the video that I have uploaded. That's why you asking this question. Actually, to enable this IC, in every IC, that is decoder or mux, there is a enable input. Let me draw it clearly. It is enable input. If you want to enable this IC in the system, you should give 1 to this enable input. If you apply 0 here, 0 voltage, so this IC will not work in that system. Sometimes you don't want to work particular IC in the system, so you will not plug in and plug out that IC. There are this enable inputs in the IC. They will operate or they will work like this. They will do this job. So 2 types of enable, active high and active low. Sometimes few ICs comes like this. They are active low enable. Whenever you will apply 0, then only they will work. Correct? Okay, so here we have we should we should assign this OR gate to the inputs, and then this function, or not function, it is a multiplexers. 8 cross 1 multiplexer will be this combinational circuit will implement the 8 cross 1 multiplexer. Okay, now the question is 32 cross 1 multiplexer using 8 cross 1 multiplexer. 32 cross 1 multiplexer using 8 cross 1 multiplexer. Four, but it is not very easy. See, for the 32 inputs, you need 5 variables, 5 selection lines. If you want to implement a 32 cross 1 multiplexer, it means this multiplexer IC will have 32 inputs. So to select each, or to select one of these inputs, we need 5 selection lines. But the question says that use only 8 cross 1 multiplexer. and which will be having only 3 selection lines. And as I have suggested that always choose the LSB sites, LSB variables as a selection line. So if you select LSB variables, so this ABC will be your selection lines. And let me call P and Q are 2 variables as the MSB site. So now, whenever you want to select this 0, this will be the first input, isn't it? And this will be the second input. So accordingly, here I have assigned ABC as the selection lines. Okay, now I am left with P and Q, and this P and Q should be connected to the input of 8x1 multiplexer. Yes, enable may be required. Actually, I don't have the solution. You need to think about it, and this is the homework for you. You need few OR gates and 8x1 multiplexer. You are allowed to use only 8x1 multiplexer and the logic gates, whatever you want. Yes, of course you can do. You can connect one, yes, PQ to this, and then again PQ to all the first IC, and in this way you can solve the question. And if you find any another simpler solution, then please let me know. What can be the simpler solution than this gate?
For example, for first enable, we can connect P bar, Q bar. Then to the second multiplexer, connect P, Q bar, P bar, Q, then P bar, and then P.
Okay, then what will be connected to the I0 and I1 and I2?
The inputs that we are using.
What input? You don't have any input. You have only 5.
Select I0 to I31.
Okay. Right. Correct. That way also work. So think about it. It may be the solution. Okay, now so we saw the multiplexers. Now we'll jump on the demultiplexers. There is another IC, there is another combinational circuit that comes into the picture where it has only one input, and according to that selection lines, there are many outputs. Exactly contrary to this multiplexer, opposite to this multiplexer, where we have 3 selection lines and 8 inputs, or 2 selection lines and 4 inputs. So in the demultiplexer, we have 1 input, selection lines, and 2 power to that selection line as the output. Correct? So is this watch is working correctly? So from the next time, whenever I see my hand watch again and again, it means there is a quiz, right? Demultiplexer. The structure of this IC is like that. You have one input and selection lines and the output lines. And according to this, if let's suppose there are n selection lines, so output will be raised to power n. And this is 1 cross raised to power n decoder or demultiplexer. So the first or the basic or elementary demux is 1 cross 2 demux, and which will be having only one selection line. So there will be two outputs. So how do we write this output in terms of Boolean function? So y0 will be what? Let's suppose there is enable input also. I should not inside this. I should write outside this. So enable input and S0 I. Again, y1 will be what? Enable S into I. Similarly, for the 1 cross 4, you will have two selection lines, that is S0 and S1, and according to that you will have 4 outputs. And it is very easy to write the Boolean function for each of this output. Now if you are very aware that if you can think about, it is very similar to decoder. It is very similar to decoder. In the decoder, you saw that one example was 3 cross 8 or 3:8 decoder, 2:4 decoder. So here what are you doing? You have two selection lines and 4 outputs, isn't it? And in the decoder, you saw that if according to the combination inside the input, one of the output will be high, or we can say each output is a min term. This produces as a min term. So the y0 in the decoder was what? I0 bar and I1 bar, isn't it? So here also similarly we can say this is S1 S0 bar and I, because this input will be reflected to that output in the demux IC. So when I connect this I as 5 volt, or you can say logic 1, this demux IC will be operating as a decoder, isn't it? Here you saw the decoder. Is there any problem in this decoder? The decoder have like this 2 cross 4 decoder, so 2 input will be there, and according to the input, if I say input is 0 and 1, so this 0-1 combination will select output y1. Rest of all the outputs will be 0-0-0. And if I say this is 1-1, so for 1-1, y3 will be high. So this is the decoder. And how do you write the decoder equation? Boolean function for each of this output? Writing it like this. So here, when I say this is the demux IC and it is operating according to the selection lines, so output is decided according to the selection lines, and whatever the input have, this will be reflected to that line. So if S0 and S1 are 0-0, it means that this output will be high, and at this position you will have only, let's suppose S0 and S1 is 0-0. So 0 bar will be 1 and 1 and I. So the output will be I. It means that at this output you will have this input, whatever it is. So if I connect this I1 and I0 here, so this IC will operate as a decoder, isn't it? Okay, so we'll implement decoder using the demux in the next lecture. Now we will have quiz. So first log in the Moodle, एंड आप पहले तो दूर दूर बैठ जाइए सभी लोग. क्विकली. और अटेंडेंस शीट कहाँ पे? प्लीज सर्कुलेट टू मी. Has everyone signed on the attendance sheet? Otherwise, you will be awarded as 0. Now, sign means your name should be there, your roll number should be there. Thank you, thank you. Thanks. Are you able to see the quiz in the Moodle? Actually, I wanted to see which type of appearance you have in your. Has anyone opened? Guys, there are so many places vacant. Please move on. First. थोड़ा आप बीच में से खाली कर दीजिए. वैसे तो मैं कॉन्फिडेंट हूँ कि तुम लोग सॉल्व नहीं कर पाओगे, बट फिर भी थोड़ा सा. गो गो ऑन दैट साइड. You also. Allow is. बताइए मुझे अपीयरेंस कहाँ पे? हाँ हाँ, मैं वही देखना चाह रहा हूँ, लेकिन मैं फर्स्ट टाइम यूज कर रहा हूँ. मुझे
Sir, I cannot find the quiz.
what?
Sir, I cannot find the quiz.
Yes, you will find in a minute. Actually, it will start from 4:50.
Sir, will the quiz be sequential?
Okay, who is this?
Sir, yes, sir. Sir, I'm asking, will the quiz be sequential or not? Means navigation is on.
अभी आपको 1 मिनट में पता लग जाएगा. What is your name?
Sir, Pratyush.
Okay. Navigation on है. You can change the question.
Okay, sir. Thank you.
आ जाओ, आप आगे आ जाओ.